Okay, well, that's everybody. Hey, everybody. I'm going to unmute you all as long as there's not a bunch of background noise. I think I got it. Unmute all. All participants are unmuted. All right, I'm going to start out with, I don't know if I've clearly defined the expectations, so I'm going to share the screen. I need. So there's already 3 spots, 3 assignments on Google Classroom, and one is for charts, one's for rates, one's for area, and you should have turned those in. So you can see I started with area and volume. If you, some of you want to check, you got some zeros in there, and if you take care of those today or tomorrow, you know, I mean, I'll get rid of those. So make sure you get those turned in. And what's expected is every day, with the exception of the day with quizzes, we have a topic, and a topic that we've covered throughout the year, of course. And there's always a worksheet that goes along with it, and they're all free response questions. And for every one of them, there's, well, I hope every one of them, there might be one where there's only 2, but there's 3 questions, and your assignment is to do 2 of those. So do 2 of the 3, and every day you should have a spot open in Google Classroom for these. So you can see after today's quiz, and that quiz should already be opened up, by the way, on Google Classroom. We're going to do velocity, tangent lines, and then story problems on velocity, and then a quiz again on the 14th. And so we won't have an opportunity to review for that one on the 14th. We won't have a Zoom session. But today we do. So we get to review a little bit. Normally on a typical class day, if we were in school, we wouldn't have a review on those days. So today's kind of a bonus. Then we have slope fields, function defined by, implicit, and so on. I don't exactly know what we're going to do for this final. I kind of spread it out a little bit, but your test is actually on the 12th. So I could potentially, I don't know what I'm going to do with that yet. So I have it scheduled out till about the 4th, and then we'll do a little bit more review up until May 12th. And so that's the test day. Now, the test, I've been told, or what I think is going to happen, is you're going to have 2 free response questions. And it's supposed to take 45 minutes, but they allow 5 minutes apiece for you to upload your answers. So total 45 minutes, but you can expect about 35 minutes of actual work. I don't know if it's going to be 9 points apiece. I can't imagine the test is only going to be 18 points. There's a lot of unknowns yet, but I know it's going to be 2 free response questions. Now, for the purposes of our final, we are going to continue on with multiple choice. And so we'll still have the 4 parts to it, but we're really going to spread it out so that it's not, back to back to back to back. And then I'll have some due dates on those. That's what I plan on right now. That's a ways out yet. And so those plans could change a little bit, and I'll keep you posted if I change anything. So any questions on what's expected? All right. Let's do this. Let's review for today's quiz. I just filled all this out last period, so I'm going to clear this and we'll go over it. All right, so one of the topics that might be on the quiz today is area and volume. So here we have a couple of curves. Let R be the region bounded by the graphs of y equals sine of pi x and y equals x to the third minus 4x as shown in the figure above. So the sine pi x, that's the top function. That's up here on top. And the x to the third minus 4x, that's the bottom function. So there's the bottom. A, find the area of R. So on part A, we're going to integrate from 0 to 2 of top minus bottom. So sine of pi x and then minus x to the third minus 4x. So top minus bottom and then dx. So let's, I'm going to use the calculator to find the answer. So math number 9, 0 to 2 of sine of pi x. And then we're going to minus in parentheses now because it's subtraction. You got to be careful when you're subtracting. X to the third minus 4x dx. Enter. Oh, 4. That's a nice number, especially using sine. But you got to make sure, I went mode. Got to make sure you're in radians. So if you're taking an AP physics test or, a lot of sciences, they like degrees. Make sure we're in radians. Letter B, the horizontal line y equals 2 splits the region R into 2 parts, right? But do not evaluate an integral expression for the area of the part of R that is below the horizontal line. So here's our horizontal line at y equals -2. We want this area. So we're going to integrate, and I got to get the intersection points of -2. That's the top now, and the bottom is the x to the third minus 4x dx. So I'll go y equals, there's a couple ways to do this. You can put -2 into y1 and then x to the third minus 4x and y2 and see where they intersect. Or I could do -2 minus x to the third minus 4x and find out where that's 0. So there's a couple options there. So let's graph this and find the intersection. So calculate. Number 5, first curve, second curve, go find the intersection. And that's 0.53, 0.53918887. The quiz and the test is not a great place to shortcut stuff. And we don't want to round in the middle of the problem. We want to round as little as possible. So there's the other intersection point, and it's a 1.6751309. And it says, if I remember right, do not evaluate. Now, on the rubric, you can see that they say, well, R is this number, S is this number, and then they write R and S. It doesn't matter what you do there. You can write it like I do or write it like they do, no problem. As long as you label stuff, then you can write whatever you labeled it. C, the region R is the base of a solid. For the solid, each cross section perpendicular to the x-axis is a square. Find the volume of this solid. So if the squares are perpendicular to the x-axis, this is one side of the square. So we have to integrate side squared, but in terms of x, with respect to x. So we're going to integrate from 0 to 2 of side squared. Well, top minus bottom is one of the sides. So we just do sine of pi x minus x to the third minus 4x, but then all of that squared because it comes from side squared dx. And I think you're supposed to find the volume. Let's kind of skip that part. It's 9.978. 9.978. So then you just use your calculator, type it in as you see it, and get the answer. Letter D, the R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by 3 minus x. So if this was the surface of the pond sitting up like this, then the depth would be 3 minus x. So the depth is getting deeper and deeper like that. So there's the line. So there's the depth. Now this is, in other words, this is your third dimension. So the area, like we did in part A, that's area, that's 2 dimensions. Here's our third dimension. So we're going to integrate from 0 to 2 of 3 minus x, that's the depth, and then times sine of pi x minus x to the third minus 4x dx. So here's your 2D, there's the area, there's the third dimension. And then you're actually supposed to find the volume. We'd plug that into our calculator and get an answer. So the answer is 8.369 or 8.370. We'll kind of skip the calculator part. Any questions on problem number 1? Let's look at charts. So concert tickets went on sale at noon. So this is noon right here. And were sold out within 9 hours. The number of people waiting in line to purchase tickets at time t is modeled by a twice differentiable function L for 0 to 9. Values of L of t at various times t are shown in the table above. So this is amount. This is not a rate, it's amount of people. Use the data in the table to estimate the rate. So we're going to estimate the rate at which the number of people waiting in line was changing. Well, that's what rate is. At 5:30 or 5:30 p.m. Show the computations lead to your answer, indicate units of measurement. Well, we don't have a function to take a derivative of, so we just have to use the information that's given. 5:30 is somewhere in there. So the best we can do is old-fashioned slope. 150 minus 126, or y2 minus y1, over x2 minus x1. That's 24 over 3. So 8 people per hour. 8 people per hour. Because this is amount of people and the bottom is hours. B, use a trapezoidal sum with 3 subintervals to estimate the average number of people waiting in line during the first 4 hours that tickets were sold. So the key word here is average. Well, if we had a function, we'd do 1 over first 4 hours. 1 over b minus a, or 4 minus 0, times the integral from 0 to 4 of L of t dt. If we had a function, we would integrate, we'd find a value. We don't have a function. So the best we can do is either a Riemann sum, a left Riemann sum, a right Riemann sum. Well, they're asking for a trapezoidal sum. So there's the 1/4, that's this piece right there. And then we're going to estimate the area under the curve, or estimate the integral using the best we can do is trapezoidal sum. So from 0 to 1, our trapezoid has a height of 1. So we're going to have 1/2 times the height, which is 1. And then the 2 bases added together, 120 plus 156. And then from 1 to 3 is 2. Now, this is why we can't use the trapezoidal rule, because one of the heights is 1, the other height is 2. If they're different, you have to figure out individual trapezoids. So then 156 plus 176, and finally 1/2 times from 3 to 4 is 1 unit. And that's 176 plus 126. I'm going to skip the calculations on it. It's 155.25. So now you just plug it in the calculator. You get 155. It must be 0.250, or it must just, just 0.25. And what is that? Average number of people. So that would be people. Letter C, for 0 to 9. What is the fewest number of times in which L prime of t must equal 0, and give a reason for your answer? So L, I don't want to say this. L of t increases. No, I don't want to do that. Oh, I know. Sorry, I want L prime of t. I do want L prime of t. L prime of t changes signs between t equals, all right, let's take a look. Now, L prime of t is how it changes, right? So from 120 to 156, this function increases. 156 to 176, still increasing as far as we know. It could have decreased in between, but we just don't know that. And then decreases between 3 and 4. So the signs change between t equals 3 and t equals 4. Also between, now we go from decreasing back to increasing right away. So t equals 4 and t equals 7. So that's increasing again, and then decreases again right away, and then continues to decrease after that, as far as we know. So t equals 7 and t equals 8. I suppose I should put between those also. And we can say by the intermediate value theorem, L prime of t equals 0 at least 3 times. So we've kind of, we give some sort of reason for why we think it's 3 times. D, the rate at which tickets were sold for 0 to 9 is modeled by this. Now they say, well, this appears to be this function. Yeah, it's pretty obvious when you see it. Just kidding. Tickets per hour. Based on the model, how many tickets were sold by 3 p.m. to the nearest whole number? So we're starting at noon to 3 o'clock of 550 TE. I guess I don't even need to say that. I can just say R of T. R of T dt. I don't have to write it all out if they tell me that's what R of T is. So how about we do calculator one more time with this? We'll go math number 9, 0 to 3 of 550. We don't really need t's. We can have x's. E to the negative t divided by 2. X. So 972, but it says to the nearest whole number. So that means round, equals 973. What is that rate at which tickets were sold based on how many tickets? So tickets. Make sure you have labels. Any questions on this one? All right. Here's the rubric. Nice to see how the points break down. Pretty straightforward on this one, actually, except for maybe letter C. There's a ton that they write, but what I wrote I think would be just fine. And then 973 tickets down here. Limits and answer. Limits is 0 to 3. Like I said, our final is still going to consist of multiple choice, how much we're going to do, how spread out it is. I'm not quite sure yet, but I'm going to try to be very reasonable to you and not try to overload you with a bunch of work to do. So rest assured that I'm going to make it fair, and I'm not going to try to, I'm going to try to spread it out. Anyway, what is the slope of the tangent to the curve for this one? This is implicit differentiation. So 2x, and then first times the derivative of the second. It would be plus the second times the derivative of the first, but the derivative of the first is also negative. So it becomes negative 2y, because the second would be y, derivative of the first would be negative 2. And then minus 1 dy dx is equal to 0. Don't forget to take the derivative of that value over there. Now let's factor out a dy dx. That'll be negative 2x minus 1. And then anything that doesn't have a dy dx will get to the other side. 2y minus 2x. So dy over dx is equal to 2y minus 2x over negative 2x minus 1. Now we're going to evaluate that when y is 2, but we have to find out what x is. So let's plug 2 into the function. So we have x squared minus 4x minus 2 is equal to 3. X squared minus 4x minus 5 is equal to 0. So x minus 5, x plus 1. So we know that x is negative 5. So let's see, 4 plus 10, is that right? Yeah.
Positive 5.
What's that?
Positive,
That's positive
5.
5. Yeah, positive 5. 4 minus 10. And then 10 minus 1. So negative 6 over 9, negative 2/3. And then we'll evaluate at negative 1, 2. So that's 4 plus 2 over 2 minus 1. So 6 over 1, so 6. Any questions on that one? Here I see a function and its derivative. So we're going to let u equal sine of x. So du is cosine of x dx. Dx lags a little bit every once in a while. So cosine dx is du. So we have integral, that becomes du, and then we have e to the u, because u is sines u. Well, that's equal to the integral of e to the u is e to the u, and we can kind of say 0 to pi over 2, but not really, because those are x values. These are now u's, so it's not really, you can write it if you want. So the integral of e to the u is e to the u, but u is sine of x, so sine of x. And now we definitely have 0 to pi over 2. So e to the sine of pi over 2 minus e to the sine of 0. Sine of pi over 2 is 1, so that's e to the first. Sine of 0 is 0. E to the 0 is 1, so e minus 1 on that one. Now, hopefully this u substitution stuff is, you're sitting there going, well, yeah. This is a review, so hopefully you're thinking this is pretty straightforward. This one, AP loves this one on multiple choice. So we're going to let u equal x over 3, which is not very obvious. It's not very obvious at all. That's why I'm showing this one. If that was 16, then it'd be x over 4. If that was 25, it'd be x over 5. So then we can multiply both sides by 3 and then take the derivative. 3 du equals dx. So now dx can be replaced with 3 du. And I can plug 3u in for x right there. So we have 1 over 9u squared plus 9. And now I'm trying to work my way to the derivative of inverse tangent. We can factor a 9 out of the denominator. That's 1 over u squared plus 1. And I have what I was looking for. So now it's 1/3. That's a 3. 1/3 inverse tangent of u. Well, we know u is x over 3. Not dx, but plus c. Good there? Any questions? All right, last one. Where does f of x increase? Hopefully this is very straightforward for you, I'd hope. We're going to take the derivative, set it equal to 0 like we've done 1,000 times this year. So x is negative 4 6, because we're going to minus 4 divide by 6. So negative 2/3. So we have negative 2/3. If we didn't know this was a parabola, but we do, this is how we could do it. We could plug -1 in. -6 plus 4, that's negative. And then if we plug 0 in, 0 plus 4, that's positive. But of course, we knew that because we know what parabolas look like. So we're increasing from negative 2/3 to infinity. Any questions on any of that? I think I'll post these with all filled in. So if you missed anything, you can fill it in if you'd like. But hopefully you know the expectations now. Even tomorrow, even though we're not meeting, we'll have a worksheet with 3 free response on it, but you only have to do the first 2. And then there'll be a spot on Google Classroom to turn those in. Make sure you're getting those turned in. I've already started to grade those. You might see some zeros. If you get them turned in, maybe shoot me an email, say, hey, I turned it in, because I don't get a notification for that. And then I'll go in and give you credit for now, but make sure we're doing that a little bit more on time. Otherwise, don't tell the other classes this, but you're my favorite class. So I miss seeing you guys. I miss having you in class. I know that there's times where you're laying in bed and you go, before all this happened, that, geez, I could really stay home today, but I don't think this is what we had in mind. I would much rather be getting up and spending time with you guys. I'm sure you'd much rather be spending time with friends and even family. But we're all in this together. We're going to get through this. We're going to face adversity. We're going to meet it head on. And I know that sometimes it's easier just to jump on Xbox and play some games rather than doing some homework. But make sure you just carve out some time. Don't let this situation hinder your education. I know you're at the tail end of it, but there's still some really good things that you could be doing in class. And I don't know. I know you guys well enough to know that that's exactly what you're going to do. That you're gonna overcome this, and we'll all be better for it. Hopefully, you're all staying healthy. Hopefully, your relatives are staying healthy, and we're just going to keep moving on. Any questions or comments? I'm going to still be putting videos together for you. I'm going to be working hard for you, and hopefully you're doing the same thing. Is the AP exam open? No. I don't know how it couldn't be. I don't know how they're going to possibly police that. I don't know the answer to that, but I just don't know how they're going to stop you. So I suppose it is until I hear otherwise. As far as my stuff, it's all open notes too. I mean, how am I going to stop you? So it might as well be. With the complexity of what we do, it'd probably be a little help, I'm sure, to look at the notes or whatever, but I can't stop you from doing that. And everything is calculator. I can't stop you from using a calculator, so I'm not even going to attempt to. So it's open notes, open calculator, so a little easier for you this year than in past years. Continue to, we'll have an assignment every day. I'm trying to limit that to make it a little easier on you. Of course, we have Friday, Saturday, and Sunday to get a lot of that done. So just have everything done by the next quiz is what I will grade a lot of your stuff the morning of the quiz. Let's put it that way. Any questions? All right, guys, great to see all of you, even though it's on a virtual world. And we'll see you next time. Bye-bye.
Thank you.
You bet. Bye-bye.